here, for example, you have this 6 ampere in the outer mesh. Where's the outer mesh? This is outer mesh. The one outside. Here it is. This is the outer mesh. Of course, 6 ampere is in the outer mesh. Then in this case, I2 equal what? Equal 6 ampere. But positive or negative? In this case, it is negative, because 6 ampere is opposite to the mesh current. Then I2 is negative 6 ampere. What about the 12 ampere? No, 12 ampere is not in the outer loop. So in this case, if it is not in the outer loop, it is a super mesh. You have to consider a super mesh. You have to consider a super mesh. We'll see this later. What about here, for example? Yes, also you don't have any current source in the outer loop. But the only one here is 5 ampere. And this 5 ampere is in the middle. Then it is a super mesh. You have to consider a super mesh. And the first step to deal with a super mesh, of course, first is the zero step is to decide or determine that this is a super mesh. If you have a current source in between two meshes like this. Second, you need to find the relationship. You need to write the equations. You have two equations. One of them is the relation between I1 and I2. Of course, 5 ampere has a relation with I1 and I2. So it is simple. Either I1 minus I2 or I2 minus I1, depending on the direction. Look at I1, for example. Look at I1. I1 is in the direction or opposite direction. It is opposite to the 5 ampere. Then I1 is negative. What about I2? I2 is positive. I2 is positive because it is the same direction like 5 ampere. Then this 5 ampere equal what? Equal I2 minus I1. I2 minus I1. Just look at the one in the top. The one in the top, this 12 ampere. 12 ampere, is it positive? It has the relation with I3 and I1. Is it I3 minus I1 or I1 minus I3? Let's see. I1 is clockwise. So here it is. Of course, it's very clear that it is in the same direction of the 12 ampere. I3 is opposite to it. It's opposite to it. So it will be I1 minus I3. I1 minus I3. It cannot be negative, positive. Must be minus. Cannot be I1 plus I3. Cannot be like this. It must be something minus or current minus current. Cannot be positive. Okay? You must have I1 minus I3 or I3 minus I1. You don't have a third option. So when you have a super mesh, you have a super mesh when you have a current source between two meshes, and the first equation you need to write is to find the relation between the two mesh currents. Second equation is that you do what? Yes, we are here. For example, here you have this 6 ampere is a current source between two meshes I1 and I2. Then what you need to do here is to remove this branch, the entire branch. So you remove everything here. So when you remove it, you end up with what? You end up with this mesh. So if you don't have the branch in the middle, then in this case you have this mesh. So that's why you call it super mesh. So what you need to do is to write or apply Kirchhoff-Voltage law for this mesh. So if we want to apply this Kirchhoff-Voltage law for this mesh, in this case we have two main currents. So we have I1 and I2. Let us write it in here. Okay, so let us write it together. So the main current is I1 and plus the other current is I2. So we have two main currents here. That's why you have plus. Okay, minus the intersection. I1 time what? In this mesh, we have only 6. We don't have 2, remember. 2 is gone. The 6 ampere and 2 are gone. So you remove the whole branch. So in this case, you don't have 2 and you don't have 6 ampere. So I1 time what? Time just 6. Okay, plus I2 time what? Time 10 and 4. 10 plus 4. Minus the intersection. Of course, this super mesh intersect with mesh number 3. In what? Intersect with mesh in two resistors, 6 and 10. 6 and 10. Okay, so this is how you write it. Equal the sources. Equal the sources. Do we have any voltage source in this mesh? Yes, I have the 20 volt, and 20 volt is positive. 20 volt is positive because it is the same direction of the clockwise. That's it. So this is the second equation. So for the super mesh, first you write the relationship between I1 and I2. It's clear here that I2, 6 ampere equal I2 minus I1. I2 minus I1. So this will be the first equation. Okay, this you see I2 minus I1 equals 6 ampere. And the second equation is like what I wrote it here, exactly like this one. Okay, this is no negative here. This is just I'm writing with a mouse, so sometimes it's very difficult to write. It's positive. Okay, so this is all about super mesh, and then of course you have mesh number 3. It is regular mesh, and you can write it very easily. This example, you have two super meshes here. You have super mesh here, and you have super mesh here because of this current source. Okay, so here you have this super mesh, and here you have this super mesh. Is this? It's the same. Sorry, I'm sorry. It is actually the same, but this nodal analysis. So we're about nodal analysis right now. So now let us write the equations for I1. The main current is I1 time what? Time 2 plus 3. 2 plus 3. So it's 2 and 3. Minus the intersection. This mesh intersects with I2 in 3 ohm. So minus I2 times 3. And intersects with mesh number 3 in 2. So it will be minus I3 time. And for mesh number 2, of course, equals 30 volt. Equals 30 volt. For mesh number, it is I2 time 3 plus 6 plus 1. 3 plus 6 plus 1. And this mesh intersects with mesh number 1 in 3. It is minus I1 times 3. And intersects with mesh number 4 in 6. Then it is minus I4 times 6. Equal the source. You don't have any source, then it is 0. Then these are the two equations. First two equations. Then this is the super mesh, I3 and I4. Then first you need to write a relationship between I3 and I4. 4 ampere equal I3 minus I4 or I4 minus I3. You don't have a third option. Okay, so according to this, I4 is positive, then I3 is negative. Then 4 ampere equal I4 minus I3. Second, you eliminate or remove this branch and you deal with this mesh here, this super mesh. So this super mesh has two main currents. So it will be I3 time 4 plus 2, 4 and 2, plus, not minus, I4 time what? 8 plus 6, 8 plus 6. Minus the intersection. This mesh, big mesh, intersects with mesh number 1 in 2. That is minus I1 time 2. And intersects with mesh number 2 and 6. Then this is minus I2 time 6. Okay, so this will be the second equation of the super mesh. If you want to solve it using nodal analysis, you don't have any issue here. You don't have any issue at all. Because this is V1 here is 30 volt. V1 is just 30 volt. So actually, one of them is already known. You have this node is already known. And then you need to write equations at V2, equation at V4 and V3. 3 equations and 3 unknowns. So calculation-wise, even for this example, nodal analysis is easier because you solve 3 equations rather than 4.